Okay, now yesterday we stopped at this example 7 by using F equal to ma equation. Today we look at one more example, which is the example number 8. All right, so what we have here, all right? So example number 8, you have a setup of an arm. So from an arm, and this one, this arm is having a round body here, and you have a surface, this straight line surface here. This round body will be sliding on this surface. Okay, so you have an arm, you have this arm, and you have a round body here, which is you can say as label as C, and you have a flat floor here, and this roller here is sliding on the surface here. So when you move A, when you move point A to the left, or sorry, to the right, okay, to the right, this ball or this roller here will slide along the slot here. So can you imagine how this slot move? You move this one to the right, this one will go into this one, and you follow the motion there. So you are given the original length or original height from the datum. This is the datum, 0.4. You have the angle that measure from the horizon here, theta, and be careful on the blue color arrow. It means when you see the blue color arrow, it tells you the motion of the object. Right, this one move to this side, means to the right hand side, and you're given the velocity, angular velocity with the theta dot above in the 0.5 radian per second. Okay, so before you solve question, you look at the diagram, see if you're able to understand the mechanism first. Right, so once you understand the mechanism and the movement, expected movement of all the things here, then you manage to answer. So you read the statement here. You have the mass, a smooth 2 kilo cylinder C here. You have the mass here. So usually when we solve chapter 2 question that talk about particles with the force and acceleration, you need to pay attention to those having weight or having mass. Okay, for example, this statement gives you have a C with a 2 kilogram cylinder. So most of the time, your attention pay to this object here, which is point C. Has a pin P, that through its center and pass through the slot arm of OA. Okay, so you have a roller C and you have a pin P. Pin P will move along these slots. If the arm is forced to rotate in the vertical plane at a constant rate of 0.5 radian per second, which is in this direction, determine the force that the arm exerts on the pack at the instant angle 60 degrees. So when you move this one with a speed of 0.5 radian per second, what is the force at here? Okay, what is the force at this point? At that particular angle there. All right, now you solve this question, you see there's a mass given, there's a theta given, there's a r given. So when you see r and theta, it fall under radial calculation. Right? Means you need to use the r axis and the r axis and the angular axis, transition axis, to do calculation. First, you still use equation of motion or F equal to ma to solve. But before you solve, you need two diagrams. One is free body diagram, one is kinematic diagram. So you draw the free body diagram first. So I'm focusing on the object C and a pin P. So I draw a free body diagram. It's a circle. I draw the axis first. This is my R axis, right? This is my R axis. This is my theta axis. So I label at theta. This is my R, right? This is my R. So all the object have mass, and mass, if you do calculation with F equal to ma, first thing after you have the axis and the object drawing, the first force you put into the free body diagram will always the weight, always the gravitational acceleration effect is the weight. Weight equal to mg through the center of the object. Of course, you can draw the arrow from here to here, yeah, because something I need to show you below here. That's why I move the weight initially at here. I move it up a little bit. Okay, as you learn in static, you can move forces in the same direction, either here or here, but in the same direction. Okay, so I move my weight from below here, I move up. Then there is normal forces that keep the ball in this position. So you have an n axis that is same direction with the weight. So again, this will be the careless mistake done by a student. Always this one will be missing in the question or in the answer. All right. So if the object have contact on the surface and it is given the r and theta, which is fall under chapter 2 question, always consider the normal force in your answer. This is one of the popular careless mistakes in exam. Normally this one will be missing when it comes to test or exam. Okay, so when you have mass with the contact of any surface, always have a normal direction. Okay, we have normal forces, N. Why there's a C? Because I focus on point C. In the exam, you don't need to write C, you just need to show that you understand there is a normal force on the object. Okay, once you have this one, you have a force of the pack, which is P here, right? So this forces is acting on this direction. F pack is this direction. Okay. So you might ask question, hey, Dr. Ang, how do I know the direction of my arrow of my pack? How do I know it's pointing this way? Can I draw this way or not? You can draw opposite direction, but later when you calculate, you will get a negative sign for your pack if the true direction is this way. I repeat, the force arrow here is not necessary you want to it's not necessary you draw in this direction. But in my case, I guess the direction is in this direction. It's pressing on the cylindrical object here, and is in the angular direction. Okay, if you draw another arrow, means you flip in your answer, maybe you flip this arrow from here to here, no problem. But later, if the answer you get for F pack here, you get negative sign, it means what you guess in your free body diagram is wrong. The direction is wrong. You need to flip the direction of the pack. Understand, yeah? This is how you find out. So I guess this is what I guess in the first impression. Okay, so once you fix the direction and then your answer in your calculation later, you get negative sign. It means that what you guess in the free body diagram is wrong. So the real one is you need to flip it back. The back direction is another way. Okay. Then you put in the angle. right? There's an angle of theta over here. So here to here is theta. Here to here is theta, is following this angle here. Okay, following this angle here. Is trigonometry problems, huh? All right. So however, no matter whether it's pointing this way or this way, the force direction, it must be perpendicular to the slot of the arm. You see this slot? It must be 90 degree to this slot. It can be either going in like this arrow, or it can be pointing out from this arrow. Okay, we don't know the direction, but we know we don't know the either is pointing out or pointing in, but we know one thing for sure: the force of the pack, the force on the pack, it is 90 degree to this slot. So it is on this axis here. Okay, yeah? So this statement is important. Okay. Next, you go for equation of motion, where you look the motion in r axis or in theta axis. You have two. So all the force in r equal to ma, and another equation will be here, will be f theta equal to ma, but in theta direction. Always have a good habit to put in the positive direction. You know that your r direction positive in this way, so just draw the direction of the positive just to remind yourself all the forces in this direction is positive. Same with this transitional angle here. So all the direction in this direction is positive. Then you start to derive all the forces inside the free body diagram into the r direction and transition direction, or the r axis and theta axis. All right. So you transfer 19.62 sine theta minus NC sine 45 equal to 2 AR. How you get 19.62? W equal to mg. What is the weight? 2. What is g? 9.81. So 2 times 9.81, you get this one. Sine theta, it will be in the r direction. Okay, this one, this purple color arrow, you can split into two. One is in r direction. One is in the transition theta direction. This is under vector chapter in mathematics. You break vector into two direction. One is towards r, one is towards theta. Okay, so from here, the both direction is positive. R direction positive. Another arrow from here is the direction of this transitional angle. So therefore you get a positive here. Positive W sine theta minus N sine 45, meaning this one you split into two also. This one in this direction and in this direction. So for the R direction, it is negative because the arrow is pointing that way rather than that way. So you split this one, you split into this direction and this direction. So this one you split into two, here and here. But the R direction is negative because it's opposite. So NC sine 45 equal to 2A. Mass is 2 kilo. In the equation of motion, F equal to ma, the unit SI for mass is kilogram. The mass of the object is kilogram. Just give you a tips when it comes to final exam, especially your lecturer, me, like to give you some trap on the unit. In tutorial, everything will seems very perfect case, but when it comes to final exam, one area that I like to trap you guys is the units. I will change this one to gram. All the mass that in the question of final exam, one of it I will play with the mass. Just take note. This is one of my favorite area in my question. Take note, eh? In question, in the test, I will change the unit. I will not use kilogram. I will use gram. Just take note on that. And in your equation, when you use for mass, use kilogram unit, unit SI. Just take note on that, yeah? Okay, I already give you hints and tips for the exam already. Okay, so you get the first equation for F equal to MA. You get the second one for the theta direction. So mg also split into two. So one of it is along the theta axis, you get positive W cos theta, W equal to mg, plus F pack with this one. This one is along the theta axis, minus n, why minus? Because you split into two, this one and this one. So this direction is opposite of the axis, you get negative. So negative nc cos theta equal to 2a theta. You have two equations. How many unknown? 1, 2, 3, 4. What about the angle? You might ask me question, Dr. Ang, what about this angle? The question already give you one hint here. He asks you to solve one particular case where the time freeze at theta equal to 60. You only need to consider when the theta reach this angle. So when you have these two equations, you substitute 60 here, 60 here, you solve one constant, solve one constant. You left out with the NC. Okay, so you have 1, 2, 3, 4 equation. This one, you still under free body diagram. Again, remind yourself you still have another diagram to help you to find another two equation, which is kinematics diagram. All right, so this diagram only solve for the force. So I upgrade this diagram, free body diagram, together with my kinematics diagram. So I add in acceleration into my diagram. Of course, you can redraw the whole diagram one more time and put it as kinematics. But in exam, you can put them together. Put in the acceleration in this direction, acceleration in this direction. Okay, AR, A theta. Recall, again, recall this is important. These two important equation will not be given. But when it comes to chapter 2 question, please memorize these two. When you want to find AR and A theta. There's another two when you consider normal and tangent. So there is another equation to find the tangent and the normal equation. This one is for R and theta. So to find the acceleration equal to R double dot minus R theta dot square. To find A theta, you use this equation, A theta equal to R theta double dot plus 2 R dot theta dot. If you have a dot, means you differentiate one time or over time. Theta also same. So you look at the information. What information you have? You have the theta dot here. Theta dot equal to 0.5 radian per second. So when you differentiate one more time with the time at the constant value, so what is the value for this one? Double dot. Double dot means you differentiate this value one more time, you get 0 because it's a constant value. All right. Okay, so if you're not sure why I'm saying when you differentiate a constant value equal to 0, go back to mathematics handbook, go into differentiation chapter, go and look for what happens if you differentiate a constant value. Okay, in this case, you differentiate this value is a constant value, you get 0. Okay. Now, there's one way to extract information from the diagram here, or from the diagram here. Your R, you can link with the theta. Your R here, you can link with the trigonometry equation. This one might be a little bit tricky, but through this example, we expect you to have this insight where you make full use of the diagram. You link this data over here, all this data with the diagram here. So first you find what is sine equation with the 0.4. There must be a reason why diagram give you 0.4. Okay, there must be a reason why the question give you 0.4 here. It give you a hint that you need to use trigonometry equation to find the relationship between theta and r. One more time. There must be a reason why the question give you a certain dimension there. In this case, it gives you 0.4. It must be linked to trigonometry of theta and r because this is a triangular trigonometry relationship. Okay, so you can find, you know that r and opposite, right? Theta is here. You see theta as your eyes. Theta, opposite, and hypotenuse, it gives you sine relationship. Sine theta equal to opposite divided by hypotenuse. So you flip the equation. You write r equal to 0.4 divided by sine theta. Right? Any one of you have issue, have trouble understanding how you get this one? Let me know. Any one of you not clear, right? Why, how I get this one? Why suddenly this Dr. An can write this one? Understand? Stop me because I just explained how you get this one. You use trigonometry equation.
Yeah, understand, sir.
Good, all right. So you get r equal to 0.4 divided by sine theta. The next one is that you rewrite the equation, or you can continue to solve differential equation on trigonometry. Okay, because later we want to use this equation to solve what is r double dot and r dot. This is an equation that we derive from the diagram here. So 1 over sine also cosine or cosec. So 0.4 cosec equal theta. You differentiate. You know this is the information that you get theta from the theta dot equal to 0.5. So theta double dot is 0. And you do differentiation. This one is differentiation. You can go back to your mathematics textbook or the cheat sheet for the derivation. When you differentiate cosec, what do you get? So when you differentiate these numbers, you will get r dot equal to minus 0.4 cosec theta cot theta times the theta dot. You'll get this equation. All right. I will not go through the differentiation step here. Okay. Here to here is mathematics procedure. So you can Google and ask how to do differentiation of cosec, or how to do differentiation of 1 over sine theta, or 0.4 over 1 sine theta. Then you differentiate one more time. Okay, differentiate one more time. This one is r dot. Okay, you rearrange, you get this one. Then you differentiate one more time. you'll get this lengthy equation, r double dot equal to something, something. Okay, now what concept is important here is that you can derive equation from the diagram and then use that use that relationship that you derive, you differentiate. Why you differentiate? Because you need to find the AR and A theta, because inside there you need to find R double dot and so on. This one is a side skew, right? It's a side skew, right? So once you find your value of your R double dot, R dot, and so on, you substitute inside, substitute 60 degree, you manage to find what is your AR and A theta. Okay, I put the information here and here. You put inside there is 2. Okay. Substitute 60 degree inside the equation after you substitute this yellow color inside there. Okay, you substitute and then you use your calculator. You'll find your AR equal to 0.070. A theta equal to minus 0.133. Okay. What is the question asks us to find? The force, right? So once you find your AR and A theta, substitute back to the question just now. The question that you derived from free body diagram just now. Okay, so you already find the AR and A theta, substitute back. So I write the 2 value here. Just now you have two equation. This one equal to this one equal to this one. One is in the R direction, one is in the theta direction. You have these 2 value. You have these 2 value. Okay. So you can find what is your NC from the first equation here. So first equation, sine theta at the instant of 60 degrees, substitute 60 degree here. This become one constant value. This one, you can press your calculator, multiply by NC, equal to 2AR. What is your AR? You just find just now. Substitute here. So this equation only have one unknown. Rearrange, you get your NC. Okay. Once you get your NC, substitute back here. You have your angle 60. You have your A theta, which is this one. Substitute here. Cos 60, because question asks you at 60. So only left out one constant unknown. Rearrange, you get your force at the back minus 0.356 Newton. You see what happened? I will get negative. What mean by negative and my diagram? When I get negative, it means that what I guessed earlier is wrong. It means the real direction of my force is going this way. It's along this way. It means that my force that I guess in my free body diagram is wrong. The real one is that it is going this direction. Yeah. Okay. Any question on the negative sign? That's why just now I say I don't know the direction of this one, but one thing I confirm is this forces is perpendicular to the hole here. So it's either going up or going down. So if earlier your arrow you draw is this direction, you will get a positive value here. If you follow my steps and you have the same guessing as I did at is going this way, your calculation at the end you get a negative sign, which means what I guess in my free body diagram is wrong. The true direction is going up rather than going down. Okay, so this is what it means. Okay, so in exam, try to understand what is the positive negative sign. What can it do to your motion? All right. So with this, I conclude chapter 2. With this, I conclude chapter 2. We'll go into chapter 3 after the break. Okay. Sorry, let me end the recording first.